You know what they say, the best time to make a follow-up video is right after the first one. The second best time, however, is
one eternity later.
Hello friends, Mircea here. In this video, we're finally doing that follow-up I promised you about my full Mikrotik and Terraform setup. It's been almost a year since I ditched OPNsense and I've gone all in. Every single networking device in my home lab is now Mikrotik. That means my router, my switches, my access points, everything. And yes, they are all managed using Terraform. Today, I'll show you my physical setup, talk about the devices I have, and then we'll walk through the logical network layout with all of my VLANs and firewall rules. Then, we'll dive into how this Terraform automation actually works in practice. Fair warning though, this will not be a step-by-step tutorial. I've got a blog post that goes into more technical details about onboarding a Mikrotik device under Terraform and managing it that way. This is more of a here's what I learned, so you don't have to suffer like I did kind of video. So sit back, grab a coffee, and let's see if automating your entire network with Terraform is actually worth it. Alright, let's start with the physical layout of my network. What devices am I actually running? Here you can see a high-level diagram of my topology. At the heart of everything is my Mikrotik RB5009. This is my main router and firewall, and it also acts as my capsman server for Wi-Fi management. Honestly, this thing is a beast for a home router. You can even run containers on it. Now speaking of Wi-Fi, I have a direct connection from my RB5009 to my CAP-AX access point. It is mounted centrally in my apartment, which conveniently happens to be where internet comes in. Then it provides both 2.5 and 5 GHz coverage in my apartment. And the cool thing about it is that it's managed entirely via Capsman, so I don't even have to worry about it. I configured Capsman on my RB5009, and then this automatically gets picked up and configured. If I were to add more access points down the line, they would also be automatically configured. For switching, I've got two CRS devices in my rack. I've got a CRS326 and a CRS317. The 326 is my main rack switch. It's got 24 gigabit ports and 2 SFP Plus ports for 10 gig connections. This is where most of my servers and infrastructure connects. Then there's the CRS317. This one is my main 10 gigabit backbone switch with SFP Plus ports. All my servers have dual 10 gig connections that go into this switch as bonded pairs. These two are then linked via one of the 10 gig ports on the CRS326. Finally, I've got a little hex in my living room behind the TV. It's technically also a router I guess, but I'm just using it as a managed switch to connect my TV and other devices without running cables all the way to the back of the rack. I've got a cable run in my apartment that goes from the hallway where the router is to the living room, and this hex is then used as a jumping off point to connect my rack to the router as well. Eventually, I plan to remove this and run a single cable from the 10 gigabit port on the RB5009 to the 10 gigabit port on my CRS326. For now, this works. Now that you've seen the physical layout of my network, let's talk about how I've organized things logically. This is where the real fun begins. I segment my network based on two main factors. Device type, so like what kind of device is this? Is it a client or a server? And trust level. How much do I trust this device not to do shady stuff on my network? Based on the answers to those two questions, everything gets dropped into one of 6 VLANs. First up is the trusted VLAN. This is for devices I completely trust. I have full control over everything from the hardware to the OS and the configuration, or at least I used to before I replaced my desktop with a Mac Mini. But you get the idea, I'm sure Apple is trustworthy, right? Basically, this is a VLAN for just our two computers. They get full access to everything in the network. No restrictions. Then there's the untrusted VLAN. These are client devices that I sort of trust, sort of don't. Think smartphones and tablets. Why do I not fully trust them? Well, these are portable devices that connect to coffee shop Wi-Fi's and airport networks and who knows what else when they're out and about. They get internet access and a carefully selected list of services they need, and that's it. The guest VLAN is pretty self-explanatory. It's basically work devices and friends' phones when they come over. Basically anything that's not mine but it needs internet access. This network is completely isolated, even to the point of using client isolation on the Wi-Fi network. They get internet access only, no local access whatsoever. IoT is, well, it's currently just for my smart TV. I made a decision a while back to keep all of my smart home stuff on Zigbee, and the TV is really the only one that couldn't fit that requirement. Yeah, I know, an entire VLAN for a single device is a bit overkill, but maybe once I drop that switch and I put the TV on Wi-Fi, I'll just drop it in untrusted or something and call it a day. For now, it's isolated and that's what matters. The server's VLAN, which I really should rename to management or something like that, is for all of the management interfaces of my servers. IPMI via JetKVM, web UIs, SSH access, that sort of thing. Ideally, this should be cut off from the internet, but for now I'm also using it as internet access for OS updates. Finally, there's the Kubernetes VLAN, which again I should rename to something like services. This is all of my services are exposed. It was initially named Kubernetes because, well, I was running everything in there, but I have since diversified my portfolio. The point of this VLAN is that it makes it super easy to manage who gets access to what using firewall rules. One thing worth noting, and I would say that this is important, is that most of my high bandwidth traffic doesn't touch the router. My NAS has interfaces in each VLAN that needs storage access, so all of the storage traffic is local to that VLAN. The only real routing happening is for internet access and cross VLAN traffic. Speaking of traffic handled by the router, I also run a WireGuard VPN for when I'm out and about, but also for friends who need to connect and consume some services that I host. The firewall rules for VPN clients are basically identical to my untrusted VLAN. Internet access, and then a carefully curated list of services that they need to consume. The thing I fought with the most here is to try to enforce a default deny model for firewall rules like I was used to in my OPNsense box. As far as I understand, Mikrotik has a default allow model, so you have to allow everything and block the specific things you don't want to pass. Coming from OPNsense and pfSense, this was a little backwards to me. So what I did then is that I added a couple of default deny rules at the end of my firewall chain to block everything, and then on top of that allow things I specifically want to pass. Sure, it's more work up front, but it gives me the peace of mind that if I didn't allow something specifically, it's most likely blocked. Alright then, enough beating around the bush. Let's get into the meat and potatoes, the Terraform automation. To be honest, I've had some trouble when I was writing up this section because I don't know how in depth to go. I don't think that a 40-minute video where we just stare at Terraform code together would be that interesting. But hey, if I'm wrong, let me know in the comment section down below. What I ultimately decided to do is to give you a high-level overview of how I have this set up, and if you want more details, there's that blog post I mentioned about getting started. With that said, let me show you what I've built. Firstly, I am using the RouterOS Terraform provider. This is essentially what makes all of this possible. It connects Terraform directly with the RouterOS API, and it will convert all of the resources you see right here into actual device configurations. The cool part about this provider is that it follows the RouterOS API very closely, so the CLI is very similar to how the resources are laid out. If you're looking at some documentation or tutorial that uses the CLI, you should have no trouble converting it to the appropriate Terraform resource. With that said, let's take a look at the code. This is my Mikrotik Terraform repository, and at the heart of all of this is this base module you see right here. Essentially, this is a Terraform module in which I put all of the common configuration for all of my devices, regardless if they are switches or routers. And this has things like the system identity, which is essentially the host name or the time zone. I'm setting up VLANs and adding them to the bridge. I am also setting up actual bridge and the bridge ports, certificates, interfaces, IP services, everything. Then, for each of my devices, I have a dedicated file. I have a router-rb5009 file, a switch CRS317, and so on. For each of my devices, I create a RouterOS provider instance with the appropriate host URL, username, and password, and then I give it an alias so I can easily reference it. Each of the devices then implements this base module we've just seen, and then passes in that RouterOS provider alias to it. Things that are common like the time zone, the NTP servers, and the VLANs are referenced via local variables, which we'll take a look at in a second. But the things like host name and the IP address and the actual interface configurations, you can see I've just hard-coded them in here because, well, they don't need to be reusable. The cool thing is that, for the most part, my switches are entirely handled by this module. This means that I only need to create the RouterOS provider instance, the module, and then a DHCP client, and that's it. My switch should be entirely configured. This means that it's only my router that will need some extra attention. There are resources which don't make sense to be included in that base module. For those, I created dedicated Terraform files per scope. For example, we have my router-capspan file right here. In this one, I configure my capspan server. You can see here I enable it, I configure the 2.4 and the 5 GHz channels, I set up the security, so the passwords for my SSIDs, the data path, so each SSID gets tagged in a specific VLAN. Then I create the configurations to put all of those together, and finally I create the provisioning rules. Similarly, I have interface lists, for example, or my DNS server, because this is global to my router. It doesn't need to be present on every device. Thus, I'm using a DNS server right here. Then I'm configuring the adblock functionality within Mikrotik, so I don't have to run Pi-hole in my infrastructure. And I'm also creating some static records by looping this static DNS local variable. Of interest, I would say, is also the firewall rules file, in which, as you guessed, I define all of my firewall rules. You can see here I have at the top my NAT rule, then I have a bunch of address lists which I make use of for the firewall rules down below, and then we have a long list of firewall rules. The weird thing about this, and how the router as provider handles this, is that the only way you have to ensure a certain order between the rules, because the order of the rules in the chain matters, is using this place before, and this references another firewall rule, obviously. The problem with this is that since you are referencing a place before, it means that you will be creating the firewall rules from the bottom up. But the problem is that the router, when it processes that chain, it will process it from the top down. This means that you should have your most restrictive rules at the bottom and then just specifically allow what traffic you want on top of that. But since you're starting to create the list from the bottom, it means that if you have a default deny that blocks all of the input, for example, well, you've just locked yourself out. What I've done to work around that is when I created the two default deny rules, which I also talked about earlier, I made sure to add a selector for the in interface to be not my trusted VLAN. This essentially means that I am dropping all forward and all input traffic that is not coming from my trusted VLAN, and this is because my desktop, which I'm using to configure everything, is in that trusted VLAN. This is how I make sure that I'm not locking myself out. Other than that, I'm also configuring my VPN here, which is also my latest addition to all of this code. Essentially, I'm making use of the Mikrotik cloud functionality to set up a DDNS, and then using the Cloudflare provider, I set up a CNAME for my own domain to the host name that is configured by the DDNS provider. Then I just set up a basic WireGuard interface and I assign an IP to it. Managing the clients that connect to my WireGuard instance is currently a manual process, mainly because I couldn't be bothered, to be honest. But yeah, other than that, it's pretty basic, I would say. I have a triple PoE client to get an IP from my ISP. I set up DHCP servers for each VLAN. And again, you can see that everything here is making heavy use of these local variables. So let's take a look at them. In this main.tf file, I have essentially my single source of truth. You can think of this as a Helm values file if you're into Kubernetes, or maybe like an Ansible vars file. Essentially, when I started working on everything, I started writing this main.tf file because I wanted to describe what would be my interface to interact with all of this. So I basically started laying out all of my information, and then when I implemented the module, I made sure to process this accordingly. You can see here I have the time zone configured, the NTP servers, which we've seen before. I'm using the Steven Black ad list for my Mikrotik ad blocking. I'm setting up some static DNS entries, and then I have a list for all of my VLANs. You can see here their names, their IDs, networks, DHCP pools, DNS servers, static DHCP lists in each VLAN, things like that. The cool thing about this is that if I want to change something, I can just change it in here, run Terraform apply, and then it should just propagate to all of my devices. Speaking of running Terraform apply, let's talk about state management for a bit, because that was a real head scratcher. Here's the problem. I can't use a remote state backend like S3 for example, because by the nature of what we're doing, I can easily cut off my internet access. Same thing goes for local options like Minio or Postgres. They're behind the very firewall or switch for that matter that I'm configuring. So my solution is, let's call it pragmatic. I'm using local state, I'm using SOPs, and I'm using Git. Basically, I keep my state file local, I encrypt it with SOPs and AGE, and then I push that encrypted file to Git. Is it elegant? Well, no, but I never claimed it is. But you know what it is? It's working. And it's working even without internet access. Alright then, let's see this all in action, shall we? Remember earlier when I said that I need to rename some of my VLANs? Well, let's do just that. Let's rename the Kubernetes VLAN into services. First things first, let me set up my environment. Lately, I've been using Mise for that. This is a tool that will install everything I need. You can see it installs Terraform, TF Summarize, AGE, SOPs, basically everything that I need, and it sets up like a Python virtual environment for them. It's pretty cool. Let me know if you want to learn more about it. I'll probably make a blog post or something. I've migrated most of my projects over to Mise. Now, with the environment set up, let's go ahead and decrypt our state file. To do that, we need to run task sops decrypt. This will decrypt both my terraform.tf state file as well as my credentials.auto.tf-vars file. Now, if you're wondering what kind of dark magic this is, well, maybe you want to check out my other video about managing secrets in Git using SOPs and AGE. In that one, I go into a deep dive in how I have this all set up. Now, I can open up my main.tf file and make the modifications that I need. So I go here and edit Kubernetes into services, and then also Kubernetes into services. Since I changed the index here, I also need to change all of the variables that reference this. So to do that, I go into the search and replace tab. I change local.vlans.kubernetes into local.vlans.services. I replace everything, and now to validate my changes, I can run task terraform plan. What this does is that it runs Terraform plan and then it pipes that output into a tool called TF Summarize. Why this is cool is because it will show us this nice table to get an overview of what the changes would be. You can see here that it would delete all of the resources associated to the Kubernetes VLAN. It will create all of the ones associated to the services VLAN, and then it will also update my firewall rules that were meant for the Kubernetes VLAN. So this all looks good, so we can run terraform apply-auto approve. At this point, this might take one or multiple applies because I don't have the proper dependencies set up between all of the resources, so it might try to create like an IP address or a VLAN before the actual interface is created. So if we run it again, hopefully this time it should just pass. And apply completed. Everything is done now. With the changes made, what we now have to do is that we have to encrypt the state file back. So we run task sops encrypt this time. And then we can just git add everything, git commit fix rename Kubernetes VLAN, git push. Now, to validate our changes, we can open up Winbox. And here you can see I'm logged into my CRS 326. You can see here we have the services VLAN and there is no Kubernetes VLAN anymore. If you log into my router, for example, again, if we go into interfaces and then VLANs, you can see services and no Kubernetes. So I would say that this whole thing worked. And that's about it. From idea to implementation, you can see for simple changes, it takes like 2 minutes and a couple of Terraform applies. Sure, for more complex scenarios, it will take more than that and careful planning, but essentially the process is the same. You modify the code, decrypt the state, apply, encrypt the state, and push it back to Git. Rinse and repeat. So, after a full year of this madness, what's my verdict? Has this whole thing been worth it? Well, firstly, I am now somewhat of an expert at recovering from lockouts, if I do say so myself. Like, if there was a certification for accidentally breaking your own network access, I'd have it. I have locked myself out so many times, I should probably just leave a console cable permanently attached to one of my switches and call it a day. Secondly, this project turned into an unexpected deep dive into Terraform state management and module development. You have no idea how many Terraform state move commands I've had to run while refactoring this thing and getting everything into modules. And don't even get me started on building that base module, like figuring out the right layers of abstraction and deciding what should be configurable and what doesn't have to be. Well, let's just say I've had quite a few iterations before landing on something that kind of makes sense. And here's the funny part. Initially, in my infinite wisdom, I thought that since everything will be terraformed, I could get by with minimal Mikrotik knowledge. Just, write some Terraform code and call it a day. Right? I ended up learning more about RouterOS and networking than I ever planned to. Turns out you can't really automate something you don't understand. Who would have thought? But here's the thing. Despite all of the pain points, the lockouts, and the late nights reading Mikrotik documentation, I wouldn't go back. There's something deeply satisfying about treating your network like code. Every change tracked, every config versioned, everything self-documented as code. I don't know, maybe it's the DevOps engineer in me, maybe I'm just a masochist, probably a healthy mix of both to be honest. But the bottom line is that this setup made me a better engineer. Not just at Terraform or networking, but in general, thinking about infrastructure holistically. So, if you're considering going down this path, here's my advice. Start small, expect factory resets, plural, and always have a backup plan, preferably one that doesn't require internet. Maybe keep that console cable handy. I know, you won't need it, but just in case, keep it handy. And that's a wrap on my year-long journey with Mikrotik and Terraform. All of the code you've seen today is available on my GitHub in my Mikrotik Terraform repository. If you want a tutorial on getting started, well, there's that blog post I keep mentioning. Links to everything will be in the description down below. Now, I'm curious, what's your take on this? Are you team GitOps or are you team ClickOps? Do you prefer this style of content or do you want to go more in-depth with the code? Drop a comment and let me know. While you're down there, don't forget to hit the like button if you found this video helpful, subscribe if you haven't done so already, and hit that notification bell so you'll get notified when I post again. Hopefully not next year this time. Thank you so much for watching, and until next time, may your pings be low and your uptime be high. If you liked this video and found it helpful and you want to see how this whole project got started, check out my original video about migrating from OPNsense to Mikrotik. Again, thank you so much for watching and have a wonderful day.